Hello, I'm Shane from Group 3. Our video is called Hassan, a true crime story. Today, I'll be talking about my function. My function is a piecewise function. A piecewise function is a function defined by two or more equations over a specified domain. My piecewise function has two equations, a cubic and a constant function. A cubic equation can be expressed as ax cubed plus bx squared plus cx plus d equals 0. A constant function is a function whose output value is the same for every input value. But before that, let's see how my function is relevant in real life. Let's focus on the story. As a recap, we saw from the video how an assassin murdered Channe in cold blood. This is where I came in. I am the medical responder who arrived at the scene of the crime in hopes of saving his life. The first thing I did was not to touch the body and first check his overall state. Once I was sure that he was capable of receiving an on-the-spot evaluation, because again, this was a crime scene and I couldn't contaminate it, I proceeded with checking his blood pressure. Checking a patient's blood pressure when assessing their physiological functions is crucial. This is how responders can tell how to proceed when faced with a patient with a unique set of medical background. Remember, not every person is the same. For example, if he had high blood pressure, that meant his blood was thicker than the average person. This could hinder my response time as I would have taken longer to assess if I could do first aid on him. This could mean he could have had an aneurysm as well, and being shot in the head, I could not have had moved him yet because I could potentially make his case even worse. This is why it is called a vital sign, because along with temperature, pulse rate, and respiratory rate, they provide an overview of how a patient may be doing prior to, during, and after the injury. Here is an example of a blood pressure reading. On the bottom of the graph is the time in seconds, and on the left is the pressure measured with millimeters of mercury. The blue line represents the outside pressure of the cuff. When doing a reading, a cuff is placed on the forearm of a person and inflated until no blood is flowing through the brachial artery on the arm. The average blood pressure of a human person is less than 120/80 millimeters of mercury. We start counting by slowly releasing the pressure of the cuff. Blood flows, and by using a stethoscope placed on the bend of your elbow directly on top of the brachial artery, you hear a pulse. The first pulse is called the systolic blood pressure. This is the indication to start counting your blood pressure with the help of the aneroid manometer gauge. The next pulse is called the diastolic blood pressure, a sign to stop counting and to release the pressure on the cuff. In the story, I mentioned that a colleague of mine had already checked his blood pressure while I was in the ambulance. This is necessary because blood pressure can fluctuate depending on your stress, diet, and activity at that moment. So when you decide to check your pressure, it is important to do it several times during the day. In my graph, you can see that there is a rise and fall and a complete flat line. This indicated to me that he no longer had a pulse and therefore was dead. Let's now take a look at the graph. The domain is all real numbers from negative to positive infinity. The range is from negative infinity to y is equal to 11.481 because of the presence of a horizontal asymptote. Let's try manipulating the equation. I'll remove the restriction x is lesser than 0 and x is greater than 0 to visualize it easily. By changing the constant of the first equation from 2 to 6, we can see it change direction at a higher point. If I change another area of the equation, per se the 4x squared to 5x squared, we can see the curve move higher. By changing the constant in the constant function, we can see it either rise or fall because the line passes through as a horizontal line depending on the number on the y-axis. That is all for this video. Thank you and have a good day.